To begin, subtract 2x from each side. And if you would like, at the same time, you can subtract 8. Otherwise, that can be done as a separate step. That leaves 3x equals negative 15. And if we divide both sides by 3, x is equal to negative 5. In number 2, we need to start by distributing because we have x's in multiple places. Distributing the 3x plus 6 plus 2x minus 1 is equal to 7x plus 8. Combining the like terms on the left, 5x plus 5 equals 7x plus 8. Now we can see that we should subtract 5x from each side, and if we choose, at the same time, we can subtract 8. Negative 3 equals 2x. Dividing both sides by 2 leaves us with x is equal to negative 3 halves. In number 3, we should first combine the like terms on the right-hand side. 4x plus 1 is equal to 4x plus 1. Now, we could start solving, but we should realize that we have the exact same thing on both sides of the equation. So no matter what we choose x to be, we will always have a true statement. So all real numbers will satisfy the problem. There are infinitely many solutions to that equation. In number 4, we need to, again, start by distributing. 3x minus 8 is equal to 3x minus 15. Now, we might continue to solve, but here we should notice that 3x and 3x are the same. If we subtract those from each side, we see negative 8 is equal to negative 15, which we immediately recognize as being a false statement. So this is the opposite of number 3. In this case, there are no solutions to the problem because there is no value that we could place for x, which would make the statement true. Next, we're asked to solve for y. So we should subtract 2x from each side. Negative 3y is equal to 18 minus 2x. Dividing both sides by negative 3, y is equal to negative 6 plus 2/3. Solving for b, if we subtract 5a from each side, we have negative b is equal to 6 minus 5a. Dividing both sides by negative 1 or multiplying both sides by negative 1, b is equal to negative 6 plus 5a. Evaluating f of negative 3 tells us to replace all the x's with negative 3 and then to simplify the arithmetic. Negative 6 minus 8 is negative 14, so that is the value of f of negative 3. F of negative 8 tells us to replace all the x's with a negative 8. So negative 16 minus 1 is negative 17. And the absolute value of negative 17 is 17. Subtract 5 from each side in the next problem to isolate x. Dividing by a negative number tells us we should flip this inequality. So x is less than 15. We're also asked to graph our solution on a number line, placing 15 in the middle of the number line because it's the most important information in the problem. We need to give some other number as a reference. You could choose 10 or 0 or anything else, frankly. I need to shade everything less than that, so I'm going to circle because my number is a boundary, not an actual solution, and I'm going to shade everything to the smaller side. Solve and graph the next problem. We have a compound inequality. We'll start by subtracting 4 from all 3 sides, so negative 14 is less than 2x, which is less than or equal to 16. Then we need to divide all 3 sides by 2, which conveniently does go evenly, and we have negative 7 is less than x, which is less than or equal to 8. If we graph this one on a number line, we're going to have negative 7 and 8. The 8 has an or equal to, so it's a closed circle, a closed-in dot, and negative 7 is going to be an open circle because there's no or equal to. The x is between these two numbers, so we're shading between the 2 points. We're asked to write the equation for the line that passes through these 2 points in slope-intercept form. So we need to start by finding the slope, and we can do that using the slope formula. Negative 3 minus 7 divided by negative 2 minus 3 gives us negative 10 over negative 5, or 2 for the slope. From there, we have some options. Personally, I would start with point slope form, and I would choose the point that doesn't already have negatives in it. So y minus 7 is equal to 2 times x minus 3. Distributing 2x minus 6 is equal to y minus 7. Slope-intercept form is y equals mx plus b, so we want y alone. Adding 7 to each side, y is equal to 2x plus 1. There are other ways that you could get there, but that's one method. Describing the graph of the line of y equals 6. Remember, this means all the points that end in 6. So no matter what comes first, you could have a 1 or a 2 or anything else, the point has to end in 6. So y equals 6 is going to be a horizontal line through the y-axis at 0, 6. Describing the graph of the line x equals 3. Now this includes all the points that start with a 3. So if we think of a few numbers in there, we realize that all of these points will stack above each other. So this is a vertical line through the point 3, 0. In number 14, we're asked to rewrite this in standard form. So we need to remember what are the requirements for standard form. The first thing I notice is a fraction. There aren't any fractions allowed in standard form. So I would start by clearing the fraction, which gives 5y equals 3x plus 10. Don't forget to distribute. Next is order. The x term has to come first, so we'll subtract it from each side and write it as the first term. Finally, the a value must be positive. So if we multiply or divide both sides of the equation by a -1, that will change the signs on all three terms and will be in standard form. Here we're asked to graph from y equals mx plus b, and unfortunately my grids don't look as good as yours, so I'll do the best that I can here. So if I put in an x-axis and a y-axis, I start at -2, and my line tells me to go down 3 and over 2. I quickly run out of space, so I also go up 3 and back to the left. I'm sorry, down 3 and over 1. I also can go up 3 and back 1 to the left. Whenever I graph, I want to make sure to go all the way across the grid to label at least 2 points on my line. Typically, we'll use the y-intercept if we used it to graph, and then we can pick any other point along the line. And we don't want to forget that the axes should be labeled x, y, and that we should have arrows on the ends of our line. When we have an equation in standard form, we always want to check and see, are a and b going to evenly divide c? In this case, they do. So we can use the simple xy chart, reminding us to first put in a 0 for x, and then to put in a 0 for y. If we put in a 0 for x, that's going to completely take out that term and leave us with -6y equals -24. When we divide both sides by -6, y is equal to +4. So we know the point 0, 4 will be on our line. When instead we put in 0 for y, that takes out the term with a y in it, leaving us with 3x equals -24. And when we divide both sides by 3, x is equal to -8. So when y is 0, x is equal to -8. I'm not going to be able to fit this on my graph as written, so I'm going to have to change my scale to go by 2s. Hopefully with your full graph, you should be able to graph it normally. So going by 2s, 0, 4 will be right here, and -8, 0 will be right here. I can see that that gives me a slope of 1 over 2. So I can draw a few more points to get a more accurate line. I'd probably want to label my -8, 0 and my 0, 4, and to make sure that line goes all the way across the graph. In number 17, it looks like we have the line y equals x, which is a nice 45-degree line. When we think of this as being y equals mx plus b, we can see that the b is 0 and the slope is 1, because those are the two numbers that don't need to be written in those respective positions. 1 times anything doesn't change, and 0 plus anything doesn't change. So putting my axes in, I can see that I'm going to start at the origin, the y-intercept of 0, and I'm going to go up 1 to the right 1 all the way across the graph, and down 1 to the left 1 all the way across the graph to get this 45-degree line. I'll label 0, 0, and just the next point, but you can pick any second point you want to label. I can't see my graph. Oh, actually, I think there isn't a number 18. Number 18 is down here. We're asked to graph x equals 1 and y equals 2x plus 1 on the same set of axes, and then to say what the 2 points have in common. So if I start by putting my axes in, x equals 1 is a vertical line through 1, 0. And 2x plus 1 starts at 1 on the y-axis and goes up 2 and over 1. We can see that these two lines have just 1 point in common. They have the point 1, 3 in common. Now, to have a fully labeled graph, I would want 2 points labeled on each line. But what they have in common is the point 1, 3. And this will be important to us in our next unit. Next, we're asked to graph y equals x plus 6 and y equals negative 3x plus 1. These are both nice y equals mx plus b lines, so they won't be too bad. I'm going to put my x-axis kind of low because that's a pretty big y-intercept. Hopefully everything fits on my graph okay. Technical difficulties here. Doesn't seem to want to write at the moment. I'll come back and fix that part later. So y equals x plus 6 is going to be up 6 spaces, and it's going to go up 1 over 1. What the heck? I'm going to stop there and I'll start a new recording because I'm having some technical difficulties.